So, if you're in the cloud world, you know the dream is all about flexibility and power. But let's be honest, the reality can feel more like, well, chaos. Especially when you're trying to manage a bunch of different cloud providers at once. Today, we're going to dive into a really cool architectural pattern that's designed to bring some order to that madness. Okay, so here's the deal. Your most important stuff, your apps, your data, it's not sitting in one safe little box anymore. Nope, it's spread out all over the place. Some of it's on AWS, some's on Google Cloud, maybe a bit on Azure, and you might even have servers in your own office. And the thing is, they all have their own little quirks and rules. And that really is the multi-million-dollar question, isn't it? When everything's decentralized, spread to the four winds, how in the world do you keep it all secure? How do you run operations without pulling your hair out? How do you find that one single source of truth in the middle of this maze?
Well, the answer is actually pretty brilliant, and it borrows an idea from one of the most complex, high-stakes jobs on the planet. We're going to start thinking about our cloud setup not as a bunch of separate islands, but more like a single coordinated airspace managed by an air traffic controller.
The key idea here is something called a control plane. Think of it as the central brain for your entire multi-cloud operation. It's the nerve center. It's where you make the big decisions, where you set the rules for everyone. But, and this is super important, it doesn't actually run your apps itself. It's the manager, not the worker. And this is where that air traffic control analogy just clicks. The tower at a major airport has total authority, right? It tells every single plane where to go, when to land, what path to take. It keeps everything safe and efficient. But the tower itself? It never leaves the ground. It's all about pure coordination. Okay, so if the control plane is the brain, then the data plane is the muscle. This is where the rubber meets the road. The data plane is basically all those different places, your clouds, your servers, where the code is actually running and your data actually lives. So to wrap up this whole analogy, the data planes are all the different airports around the world. You've got JFK, Heathrow, you name it. Each one is doing its own thing, but they are all listening for instructions from their control towers to manage the planes, which are your apps and your workloads that are constantly landing and taking off. All right, the analogy makes sense. But how does this stuff actually work with real technology? Let's pop the hood and see how this all comes together in a practical system. In the real world, you're looking at tools you probably already know, like Kubernetes or a service mesh like Istio. These often act as that central control plane. From this one spot, you can create a security policy and just know it's being enforced everywhere. You can control how your services talk to each other, even if one is in North America and the other is in Europe. It's just incredibly powerful stuff. And the way it works is beautifully simple. Step 1, an architect or an operator defines a single global rule in that central brain. Something like all traffic between services must be encrypted. Step 2, the control plane automatically figures out how to translate that rule for AWS, for Azure, for all of them, and pushes it out. And finally, step 3, the apps just do their thing, running on their own clouds, but now they're all following that one central rule. No manual work needed. This all sounds fantastic, right? Central control, simple operations, automation. What could possibly go wrong? Well, that brings us to the really critical part of this explainer. You have to understand the risks involved. This is the question that should give any cloud architect nightmares. What happens to all those planes in the sky if the air traffic control tower suddenly loses power and goes completely dark? If your central brain goes offline, does your whole multi-cloud system just fall apart? This potential catastrophe really breaks down into 3 big worries. First up, trust. If the brain is offline, how does a service running in AWS even know it can trust a request coming from a service in Azure? Who's vouching for it? Second, connectivity. Can those services even find each other anymore to talk? And finally, the big one, failure mode. Does the whole system just grind to a halt, or is it designed to fail gracefully where the individual airports can kind of manage on their own for a while? You see, this isn't just a tech decision. It's a huge strategic trade-off. It's a fundamental choice you have to make when you design these kinds of systems. And this really lays it all out, doesn't it? On one side, you've got all this incredible power. One place to see everything, easier operations, consistent security. It's a huge win. But on the other side of the coin, you have some serious peril. You've just created a single point of failure, a ton of complex dependencies, and if something goes wrong, the blast radius could be enormous. That's the dilemma right there. This quote just hits the nail on the head.
The entire engineering challenge is to get all the benefits of that central tower, all that coordination and power, without turning it into a catastrophic vulnerability. The whole game is building a control plane that is resilient.
So as we wrap this up, here's the thought I want to leave you with. This pattern, this idea of a central brain for the cloud, is getting more and more popular. But is it the elegant solution that's finally going to tame multi-cloud chaos? Or are we just building a more sophisticated, more fragile house of cards? The answer? Well, it depends entirely on how well we build that tower.